Hello everybody. My name is Stefan Rizzo. I'm Export Sales Area Manager from Dixel and Emerson. I would like to present a case studies that we apply and implement in Australia. The purpose is that we know F-gas regulation is asking for new technology for solution that is with a low GWP refrigerant, and the CO2 as natural refrigerant with GWP equal to 1 is an effective replacement to the high GWP refrigerants. The use of the CO2 as a refrigerant brings some challenge on the system designs to guarantee the efficiency, often requiring more complex systems to deliver comparable performance of HFC refrigerant, as we saw also in the previous presentations. The iProRec provided by Dixel as control solution can help at the application, keeping the high performance of the systems. We can see a case study in Australia with a transcritical CO2 booster application in which was designed according to the exact environmental conditions. So in terms of complexity of the systems, the complexity is also related to the site, to the conditions, the environmental condition where these systems is applied. So in these cases, the strategy that has been used in the systems is using a parallel compression, and to keep the compressor working in the best performances, there is a oil management algorithm, and to compensate some peak of heat that is in the condition of the place where the system was installed, is using adding cooling expansion that is an adiabatic cooling systems. Just to introduce the situation and the analysis of the case studies, the main subject that we have to analyze is the environmental condition that is in this place of Australia is a potential warm area where the temperature can reach very high peak. The case studies is a new supermarket of the Woolworths chain. The location is Vadalba, the city is Vadalba, close to Sydney. The supermarket is a medium-large supermarket with about 3,000 square meter. The systems for the medium high temperature require about 200 kilowatt of cooling power, and the low temperature line 34 kilowatts. This is the place where the installation and the supermarket is located. Before going to analyze the details of the systems, the first subject to analyze before to design properly the rack and the systems is to analyze the temperature and environmental conditions of the place. If we look at the average annual temperature, it looks like Vadalba is very good weather conditions, very good warming temperature. So the average, the monthly average is in the range of 21, 22 degrees as maximum temperature, and the minimum is around 14 centigrade. But if we check the daily record temperature, we can note that there are some peak of temperature up to 45.8 degrees Celsius, and the lower temperature is reaching approximately the 2 degree. So that what we have to take care about the system is the maximum temperature. And if we are talking about a supermarket, we have to cover the requirement even in the peak of temperature. We cannot give the systems switching off because of the peak of temperature. If we analyze how many hours in 1 year, typically, the ambient temperature is overcoming the 40 degree, we can note that it's just a few hours. It's about 6 hours per year. Above 35 degree is roughly 3.1 days. Above 30 degree is about 15 days. The number you can see in the last diagram is in days. So even for few hours per year, we have to define a system that is suitable to cover the peak of requirement, the peak of heat. So high temperature for a few days a year drive to auxiliary cooling device. We have two possibilities. We can oversight the systems to be able covering the peak of heat. But this is not typically suggestible in these conditions, specific condition with only few hours per year is overcoming the higher temperature. Oversighting the systems is becoming not convenient. The alternative is to introduce a suitable system in the configuration, adding some strategy, creating a little bit more complex systems able to cover this peak of requirement. Let's see later on which could the solutions adopted in this site. So the heart of these systems is the compressor rack. These are the characteristics of the compressor rack. Is able to cover in the medium temperature line 200 kilowatt. Really there are two compressor racks. One for the high temperature line and low temperature. The other one suitable for the medium temperature and low temperature. Each medium line temperature is covered by 3 compressors, 2 on off and 1 variable speed. The low temperature line, the requirement, the cooling capacity for the low temperature line is 34 kilowatt, as I said, split in 2 compressor racks. Each one for the low temperature line is supported by 2 compressors, 1 on off and 1 with variable speed. So modulated compressor. The trick, the systems is to cover the peak is used the parallel compressor line. In this case there are 2 compressors, 1 on off and 1 variable speed. Everything of the compressor is managed by the iPro rack, that is a controller, programmable controller managed and made by this. The adding feature to compensate the peak is an adiabatic device added to the gas cooler. The rack is manufactured by Heatcraft Kirby. In terms of showcases, in terms of inside the supermarket, there are for the medium high temperature line 56 cabinets and 8 cold rooms in the high temperature and medium temperature, covering the 200 kilowatt. Each cabinet, each showcase and each cold rooms are managed and controlled by the XM687D module, and the user interface, the keyboard is the CH620. The low temperature line is made by 15 cabinets, freezer cabinets, and 4 freezer rooms. The total kilowatt required is 34 kilowatt, as well the same controller for each cabinet and for each cold room. The producer is Hussmann in this case. The systems in terms of graphic, the graphic of these systems made in evidence the main component. We can see the low temperature line supported by the 2 compressors, the medium temperature line supported by the 3 compressors. The other component of the system is the gas cooler, the high pressure valve, the flash tank, the bypass valve, and the parallel compressor line. Adding, to complete the system, there is the oil management to make the compressor working in the best performance, in the best condition all the times. So this is the 2 points we would like to underline in the next slide. The control panel is made by, in the control panel there are the compressor rack, IPRC 215, there is the one expansion, the driver for the valve, to manage and to control the high pressure valve, the bypass, the flash tank bypass valve, and the expansion valve. And the VisoTouch is the user interface, is a new touch user interface that gives you the information in a very easy way to monitor what is happening in the systems. The gas cooler is supported by adiabatic cooling systems that is spraying water, and thanks to the water evaporated around the gas cooler, around the fins of the gas cooler, permitted to decrease the around temperature and boosting the gas cooler functions and capability. If we underline what is happening specifically in the parallel compression for warmer climate, this is a solution to permit designing the systems and working in good performances, the systems even in a warmer climate. We decided, the company, the consultant, designed to consider the parallel compression line. In this case, the parallel compression offers better performances because moving CO2 from flash tank to gas cooler makes less compression work in comparison to the flash gas bypass cycle only. The parallel compressor are automatically activated when the controller detects a consistent refrigerant mass flow from the bypass valve to the medium temperature suction line. The flash tank bypass valve kept on working even higher pressure set point. At the higher pressure set point, even the parallel compressor are working. So both are used. In this case, the bypass valve is used as a safety device. In this case, the result is improving the total COP and the cost-effective CO2 solution for warmer. It is an effective CO2 solution for warmer climates. To make the compressor working in a proper way all the times, the algorithm permitted to manage the oil, the quantity, the amount of oil that is present in the oil receiver. And the function, in this case, in these specific systems, is using the pressure differential oil control between the parallel suction line and the oil receiver. Is kept about 5 bar differential pressure between the oil receiver and the flash tank. The oil injection is managed by the oil valve that is in the small valve between the oil separator and the oil receiver. In terms of safety function, in case of low oil signal from the oil receiver sensor, the compressor, the variable speed compressor, is increasing the speed to boost and to bring the oil that is in the pipeline in the oil separator and then in the oil receiver. This is the result from the installation, a real data collected during a certain period of time, in which you can see that the pressure of the oil is following the requirement, the green line. The oil receiver pressure is followed by the liquid receiver pressure. This permitted for all compressor working in the best way. About the peak, we was talking at the beginning about the peak of the temperature for just few hours per year. In this case, a suitable solution could be an adiabatic system that is switch on, controlled by the IPROREC. So the system, the IPROREC is controlling also when is convenient to activate and deactivate the adiabatic expansion. In this case, this specific site has been decided to switch on the adiabatic cooler when the outside temperature, gas cooler outlet temperature, overcomes the 36 degree, and switch off when the gas cooler outlet temperature is going below 28 degree. Obviously, there is also an hysteresis in the switching on and off. During the normal operation, the differential temperature, that is the gas cooler outlet temperature, so minus the operative ambient temperature, is typically close to 2 degree for a gas cooler design. Considering in the real cases, during the switch on of the adiabatic systems, the real effect is to have a delta of temperature, an effective different temperature of about 8.4 degree. The design of the systems was around 9 degree. So in the real conditions, the effective is according to the design. In these cases, when the adiabatic cooling is working, the fan of the gas cooler has maintained at a fixed speed to create the airflow that is suitable for better performance of the adiabatic cooler. If you look at the graphs, you can see in the medium line, the red line, and the blue one, the light blue one, the real effect of the adiabatic cooler on the gas cooler outlet temperature, the effect of that is about 8.4, about 9 degrees Celsius. This simple solution permits to the systems working in the best conditions, even when the outlet temperature, the ambient temperature, is going more than 45 degrees, as we saw at the beginning of the presentation. So, in terms of conclusion, the CO2 is an effective replacement to IGWP refrigerant. It's a green solution. The adopted technical solution like parallel compression and adiabatic cooling expansion have made the CO2 system working also in warmer area. We can say moving the CO2 equator southward. IPROREC, the controller with the integrated software application, with integrated logic, can synchronize, coordinate, and manage efficiently different CO2 systems design, from the simpler to the complex one. The test in real working condition, the Vadalba case study is an example, highlighted the efficiency of the application developed by the Dixell Emerson controller and used and applied in the IPROREC. Just to summarize, the algorithm we saw in the case, specific case of Vadalba, is only one of the possibility of the algorithm of the system that can be designed. Just to underline, compare with the previous graphics, we can see here the heat reclaim, two different, and it's possible to run in simultaneously, two different heat reclaim functions. That is something that could be helping in some cases for floor heating and for domestic tap water. There is also possibility to manage the desuperheat systems in the low temperature line, and other functionalities, like for instance HVAC cooling control. Just to complete the presentation, the systems we talk about the HyperRack can be configured in different systems, in different configurations, according to the complexity of the design. So it could be just the controller, or if we need more input-output, we can add the expansion. We can connect the driver for the high pressure valve and the bypass flash tank valve with a relative backup battery. It is possible to manage meter reading and other options, as well connecting the supervisory systems. This permitted to have a really unique systems that is able to manage from the simpler to the more complex configuration. Just to finish, there is the touch display that permitted to easily monitoring and configure the systems. This is just an example with a Synoptic to enter in a very short time to the all functionalities of the systems. Thank you.